vast hall of the International Engineering Summit in Munich hummed with quiet conversation as experts from different corners of Europe settled into their seats. Tall glass windows framed the cold gray afternoon outside. But inside, the atmosphere buzzed with confidence, prestige, and the comfortable arrogance of people who believed they had mastered the rules of the physical world. At the front of the room, Dr. Maria Reyes adjusted the microphone. She was calm, too calm, some might say, given that she was about to present research that many in the room would consider laughable. She had spent years preparing for this moment, collecting evidence, refining her studies, and assembling what she believed was an unshakable argument. Still, she knew what was coming. Western engineers had always dismissed indigenous construction, especially when it came from countries like hers. She didn't expect applause. She didn't even expect polite silence. But she wasn't here for validation. She was here for truth. As the lights dimmed and her first slide glowed on the screen, she began her presentation. The hall shifted from casual murmur to attentive silence, until one word appeared on her title slide: bamboo. The reaction was instantaneous. It rippled through the audience like a spark through dry leaves. A few smirked openly, others exchanged skeptical glances, some laughed quietly, as if they couldn't believe an engineer had flown halfway across the world to talk about a material they associated with backyard furniture and children's toys. No one, however, reacted quite like Dr. Klaus Hoffman. Tall, imposing, his gray hair neatly combed back, Hoffman was widely regarded as Europe's most respected bridge architect. His stern expression was familiar to nearly everyone in the field, a symbol of traditional engineering discipline. And now that expression twisted into barely concealed ridicule. When Dr. Reyes advanced to her second slide, an image of woven bamboo joints and traditional Filipino construction techniques, Hoffman couldn't contain himself. He stood up, not bothering to wait for the microphone. "Are we truly entertaining this?" he said loudly, addressing the room more than the presenter. "Bamboo, as a structural material worthy of international consideration? This is disappointing." The crowd erupted into scattered laughter. Hoffman continued, waving dismissively at the screen. "Bamboo decays, it softens, it breaks. There is a reason steel and reinforced concrete are the global standard. They endure, they perform. They don't crumble in the rain." A French architect chimed in from the front row. "Perhaps these methods are suitable for decorative walkways in rural villages," he said. "But we are discussing actual infrastructure, bridges that carry responsibility, and real loads." Dr. Reyes listened without flinching. Their reaction didn't surprise her, not even a little. For most of her career, she had fought the same battle. To them, traditional engineering was folklore, not science. Craftsmanship handed down through generations wasn't considered legitimate unless it came with European textbooks, peer-reviewed journals, and million-dollar equipment. She waited patiently for the room to fall silent again. Then she clicked to the next slide. A photograph filled the screen. A hanging bridge stretching across a deep forested gorge in Bohol. Her voice was soft but steady. "What if I told you that a bamboo bridge in my country has survived more than a century? What if I told you it remains structurally sound, supports thousands of people, and has outlasted concrete bridges nearby that have collapsed during powerful storms?" The room went quiet, not because they believed her, but because the claim was too absurd to ignore. Hoffman's laugh broke the silence, short, sharp, incredulous. "Impossible, completely impossible. Show me the maintenance records, the reinforcement treatments. Bamboo cannot hold under load for more than a few decades, let alone a century." Dr. Reyes didn't blink. "I know your doubts," she replied calmly. "So I invite you, and any team you wish to bring, to visit the bridge yourselves. Bring your instruments, bring your methods. Test everything. If what I'm presenting is false, I will retract my research." She let her words settle before finishing. "But if it's true, then you must reconsider what you think you know about sustainable engineering." A challenge, a direct one, and one Klaus Hoffman could not refuse, not with the international engineering community watching him, waiting to see how he would respond. His pride wouldn't let him walk away. "Very well," he said, trying to sound unimpressed. "We will visit this bridge of yours, and when we find the flaws, and we will, I expect your public apology." Dr. Reyes didn't smile, but her eyes did. "That won't be necessary," she replied. 3 months later, after a long flight and an even longer drive through winding provincial roads, Hoffman and his team arrived in the Philippines. The humidity hit him first, a thick, warm air so different from the crisp climate of Germany. Locals greeted them with warm smiles as they led the group deeper into the countryside. The bamboo groves towered overhead, whispering softly in the breeze. Hoffman found the environment disorienting. Everything felt too natural, too alive, too untamed for something as precise as engineering. Finally, after passing through dense greenery, the trees opened up to reveal the bridge. It stretched gracefully over a deep gorge where the river shimmered far below. Moss-covered cliffs framed it, and the entire structure appeared impossibly delicate, an airy ribbon suspended over the ravine. "This is it?" Hoffman asked, stunned at how fragile it seemed. "This is the structure you claim defies engineering logic?" One of his assistants began scanning it with a handheld analyzer. Another crouched near the joints, expecting to find rot or termite damage. But the bamboo, aged and golden, showed no obvious decay. The bindings, made not of metal but hand-woven rattan, were still tight. The joinery, crafted with a precision that required no screws or nails, appeared untouched by time. The elderly caretaker, Mang Thomas, approached them slowly. His steps were steady, familiar, confident, like a man who had spent a lifetime caring for something precious. "This bridge has been here longer than any of us," he told the team with quiet pride. "My great-grandfather helped build it. My father cared for it, and I inherited the responsibility." Hoffman folded his arms. "You must have replaced it many times. Bamboo simply cannot survive this long." Mang Thomas chuckled softly. "No, sir. The bamboo is the same, treated, cured, and positioned the way our ancestors learned through centuries. We replaced a few bindings over time, yes, but the bones of this bridge remain unchanged." Unconvinced, the German team began their tests. They measured moisture content, expecting high levels of rot, yet the readings stayed near optimal. They measured rigidity and internal fiber quality. The data contradicted everything in their textbooks. They analyzed the rattan bindings. The fibers showed no artificial preservatives, nothing made sense. By evening, their instruments recorded a structure that shouldn't exist, not under the rules they believed were absolute. Dr. Weber stared at his tablet, shaking his head. "Klaus, something is wrong. These readings shouldn't be possible. Bamboo in this climate should have degraded decades ago." Hoffman refused to accept it. Then they applied chemicals, modern ones. "Hidden treatments," Mang Thomas overheard and responded gently. "Nothing modern was used. We only apply what our elders taught. The bamboo is smoked with specific wood at certain heat for hours. Then it is soaked in salt water mixed with plants we've known since childhood." Hoffman snorted. "That isn't engineering. That's folklore." The old man smiled, not offended. "Maybe so. But folklore keeps this bridge standing while your new bridges fall apart after a few storms." Hoffman bristled with irritation, but his team stayed silent. Because the old man wasn't wrong. Night fell gently over the gorge, carrying with it the soft hum of insects and the rhythmic whisper of bamboo leaves swaying in the warm Philippine breeze. The German engineering team worked under portable lamps, their faces illuminated by screens filled with readings they could not reconcile. Numbers bounced, stabilized, and repeated, each telling a story that clashed violently with their rigid beliefs. Dr. Klaus Hoffman sat apart from the others, staring at the bridge as if it were mocking him. For 30 years he had lectured about the predictable nature of materials. Steel, concrete, aluminum. These were the pillars of modern civilization, reliable because they obeyed the rules. But this bridge, made of hollow grass and tied together with vines, seemed to defy the very principles he had dedicated his life to, and he despised how uneasy that made him feel. Dr. Maria Reyes observed from a few meters away, knowing exactly what he was going through. She had once experienced the same disbelief, the same refusal to accept what her eyes and instruments showed. She had been trained in Western academia too, molded by the same assumptions. But unlike Hoffman, she had allowed herself to listen when indigenous craftsmen explained their traditions. "Klaus," she said softly, approaching him, "you look troubled." He didn't look up. "Your team's reactions don't concern you?" "They do," she admitted. "But not in the way you think. I've seen this bridge survive storms that tore apart concrete supports nearby. I've watched people walk across it every day, confident it will hold. I spent years studying how it was built. I know what you're feeling." He scoffed. "Enlighten me." She sat beside him, folding her hands on her lap. "Your concern isn't whether the bridge is strong. It's that its strength doesn't fit your understanding. And if this one thing is wrong, How many other things might you have overlooked? Hoffman clenched his jaw, but he couldn't deny the truth of her words. Before he could respond, Dr. Weber approached, tablet in hand. His voice trembled slightly, not from fear but from awe. "Klaus," he said, "you need to see this." Hoffman took the device and glanced at the data. Then he stared harder, as if by will he could make the numbers change. They did not. The bamboo fibers showed durability far beyond expected lifespan. Moisture retention stayed stable. The rattan bindings remained tight despite the age. "What's the explanation?" Weber asked. Hoffman stood abruptly. "We run more tests. Tomorrow we do load testing." He said it as if the idea was his own, but deep down he knew it was desperation. If the bridge failed under pressure, everything would fall back into a world he understood. The universe would make sense again. The next morning, villagers gathered to watch. The Germans set up calibrated weights and ropes, constructing a system that would distribute mass evenly across the bridge. They had calculated an expected failure point based on the bamboo's estimated tensile strength and the age-related degradation they assumed must exist. Dr. Reyes and Mang Thomas stood at the edge, observing in silence. "Are you nervous?" she asked the elderly caretaker. He shook his head. "This bridge knows how to carry burdens. It has held the weight of storms stronger than metal bridges. It will not be afraid of iron blocks from Europe." She smiled at the poetic confidence in his tone. The test began. 3,000 kilograms, nothing happened. 5,000, still nothing. 7,000, only a gentle sway. Hoffman's face tightened. He checked the readings again and again, looking for an error. But the instruments confirmed everything. The bamboo was holding. He ordered more weight. 9,000 kilograms, no significant deflection. 10,000, the bridge still refused to fail. Dr. Weber exhaled in disbelief. "Klaus, this bridge is outperforming our reinforced wood prototypes. And it is older than our oldest laboratory facility," Reyes added, not to taunt him, but because the truth deserved to be acknowledged. Hoffman stepped onto the bridge himself, walking slowly along its length. The structure flexed under him, not in weakness but in the graceful way bamboo is designed to move. He felt the bridge breathing, alive in a way concrete never could be. "How?" he whispered, not expecting an answer. "Maybe," Dr. Reyes replied from behind him. "Because the people who built it understood bamboo the way we understand steel. Maybe they knew their material in ways we never bothered to learn." He said nothing, because for the first time in his career he had no rebuttal. The third night in Bohol brought a storm. Clouds gathered on the horizon during the afternoon, building into a wall of bruised purple and gray. By evening, wind roared through the bamboo groves and rain began to hammer the roofs of the nearby homes. Local officials urged the engineers to move to a safe structure, a concrete building reinforced for typhoons. But Hoffman refused. "I need to see how the bridge behaves," he insisted. Dr. Reyes attempted to reason with him. "This is dangerous, Klaus. Typhoons here are not like the storms you know in Germany." "That is exactly why I'm staying," he said stubbornly. His team reluctantly stayed with him. Inside a reinforced viewing shelter, they watched as the storm struck the gorge. Wind howled, ripping branches from trees. Sheets of rain blurred the world into shifting shades of gray. The river below crashed against the rocks as if trying to escape its own fury, and the bridge moved, it danced. It swayed in wild arcs, and for a moment, the Germans thought it would snap. But the bamboo didn't resist the wind. It embraced it. Flexibility became its armor. Its motion became its survival. "Look at that," Weber whispered, mesmerized. "It isn't trying to be stronger than the wind. It's working with it." Hoffman gripped the windowsill tightly. His knuckles turned white. He had never seen a structure behave like this, not without cracking, bending, or collapsing. His mind raced through everything he knew: stress, tension, shear force, torsion. None of it prepared him for what he was witnessing. The storm raged for hours. But when dawn arrived and sunlight broke through the thinning clouds, the bamboo bridge stood exactly as it had before the storm, steady, unmarred, quietly triumphant. Meanwhile, reports came in that a steel footbridge several kilometers away had twisted under wind pressure. A concrete overpass had developed deep cracks. When Hoffman heard that, something inside him shifted. His disbelief was gone, his pride was gone. What remained was a humbled man standing before something older and wiser than he had ever imagined. And later that morning he approached Mang Thomas. Rainwater still glistened on the old man's hair, but his smile was gentle and warm. "I've spent my entire life studying engineering," Hoffman said. And yet this bridge has taught me something I never learned in any classroom. The caretaker nodded slowly. Our ancestors did not try to conquer nature. They watched it, they listened. They understood that the strongest things are those that know how to move. Hoffman swallowed hard. I want to study your methods. I want to understand everything, every step, every tradition. You are welcome to learn, the old man replied. But you must understand something first. We do not build this bridge with only our hands. We build it with patience, observation, and respect. If you learn those, you will learn the rest. Behind them, the sun rose over the gorge, casting warm light across the bamboo structure. It gleamed like gold, alive, enduring, defiant of everything modern engineering believed was possible. Hoffman knew then that his life's work was about to change forever. The morning after the storm felt like a different world. The sky, scrubbed clean by hours of raging winds, shone in a soft blue that made the surrounding hills look newly born. Mist lingered in the gorge like a delicate veil, curling around the bamboo beams of the bridge as if paying homage to what had survived the night. The German engineers moved slowly, subdued by what they had witnessed. Gone were the arrogant strides, the prideful glances, the quiet judgment they carried upon arrival. Some of them hadn't slept at all, replaying the storm over and over in their minds, trying to rationalize how an ancient bamboo structure stood firm when modern ones had failed. Dr. Hoffman walked toward the bridge with a heavy, contemplative silence. He paused before stepping onto it, tracing his fingers along the bamboo railing. The surface was smooth from decades of hands touching it. Tourists, villagers, children running across it on sunny afternoons. It was as if the bridge held memories, not just weight. Dr. Reyes joined him quietly. You look like someone who's just met gravity for the first time, she said gently. He let out a long, slow breath. Maria, everything I thought I knew, everything I've taught, everything I've built, it feels suddenly incomplete. Incomplete isn't the worst thing, she replied. It means there's room to grow. He turned to her, his eyes troubled and searching. How did you accept it? The first time you realized this bridge wasn't behaving the way it should. She smiled slightly. I stopped trying to force it into the categories I knew. I let the bridge show me its own rules. He looked back at the structure, his voice barely above a whisper. I don't know if I can do that. You can, she said. But you have to let go of the idea that modern engineering has all the answers. Hoffman didn't respond, but he didn't disagree either. The team spent the next 3 days immersed in observation, note-taking, and interviews. If they had expected this to be a simple case of misreported facts, their assumptions had been shattered. Instead, they found themselves facing a method of construction that blended empirical knowledge with cultural wisdom, tradition with practicality. Mang Tomas demonstrated everything patiently. He guided the engineers through his small workshop built under a large mango tree. Bundles of bamboo leaned against the wall, each sorted by age, thickness, and where it had grown on the stalk. The old man picked up 2 poles and held them out. This one is for the walkway, he said. It bends well but stays strong under load. This one is for the handrails. It's older, stiffer. Hoffman examined both pieces closely. He could see differences, but nothing obvious enough to decipher the old man's certainty. How do you know which is right, he asked. Tomas tapped the bamboo lightly with his knuckles, listening closely. Each one speaks. The sound tells you if it's ready. The color tells you how it was grown. The smell tells you if it was cured well. Dr. Weber leaned closer, fascinated. Smell? Yes, Tomas said. Bamboo that was smoked correctly has a scent that lasts long after the process. If it was smoked too fast, the smell is harsh. If it was too slow, the smell fades. Balance is important. Reyes watched the Germans study the poles more carefully, their skepticism slowly dissolving into curiosity. What about the curing process, she asked. The caretaker walked to a clay pit covered by large stones. He removed the stones, revealing bundles of bamboo soaking in a shallow mixture that gave off a faint herbal aroma. Salt water and plants, Tomas explained. This mixture protects the bamboo from insects and helps it resist moisture. But it only works if you soak it long enough and only if you use the right plants. Hoffman crouched beside the pit. And you know all of this from tradition? Tradition, Tomas nodded. Observation. Mistakes made by those who came before us. We learn by doing, we remember what works. The idea that engineering knowledge could be preserved through ritual rather than equations seemed to unsettle Hoffman deeply. You said you smoked the bamboo, Weber interjected. Why smoke? Why not just dry it in the sun? Tomas smiled knowingly. Sunlight makes bamboo brittle over time. Smoking keeps insects away, cures the fibers, and strengthens it. The smoke must be from specific wood at a steady heat. Too hot, and the bamboo cracks inside even if you cannot see it. Too cold and it does nothing. The German team exchanged glances. Scientifically, the explanation made sense, but the precision of it, the awareness of temperature, timing, material response, was more advanced than they expected from so-called primitive methods. Hoffman rubbed his temples. "You've been doing this for generations?" "Yes," Thomas answered, "and we remember every lesson." He paused, looking directly at the German architect. "Maybe your world builds fast, but our world builds to last." Hoffman felt the words strike him like a hammer. By the fourth day, they began mapping the structural geometry of the bridge. Using advanced software and 3D scanners, they created a digital model of the entire structure. What the software revealed made Hoffman freeze mid-breath. The bamboo beams weren't arranged randomly. Their placement formed a complex system of distributed load paths and shock absorption zones. The entire structure functioned like a woven basket, flexible yet incredibly strong. Every rattan binding anchored tension in a way that redirected stress efficiently during movement. "We could not have designed this better with modern tools," Weber murmured. Reyes smiled faintly. "That's because it wasn't designed with tools. It was designed with patience." But what fascinated Hoffman most was the geometry of the anchoring points. The bamboo was positioned with precise angles that aligned with natural wind flow and water direction in the gorge. The bridge used nature's force instead of resisting it. "It's almost alive," he said. Reyes nodded. "That's what indigenous builders understand. They don't fight the environment, they build with it." The longer Hoffman studied the digital simulations, the more he felt his foundation tremble. For decades, he believed modern engineering stood at the peak of knowledge. Now he was staring at a structure that had survived a century longer than some of the most celebrated projects in Europe. A structure built with no machines. No textbooks, no academic theories. Only wisdom passed from one human heart to another. On the fifth day, Hoffman asked to walk the bridge alone. The others stayed behind, giving him space he didn't ask for but clearly needed. The bamboo walkway creaked softly under his weight, not from strain but from life. Beneath him, the gorge stretched out in a breathtaking sweep of green and stone. The river flowed steadily below, glittering like a silver ribbon in the late afternoon sun. Halfway across, he stopped. His breath caught in his throat. He felt humbled. Truly humbled, not defeated, because this wasn't humiliation. It was revelation. All his life, he had believed strength came from rigidity. He believed good engineering meant control, precision, strict adherence to formulas and materials that behaved predictably. But this bridge had shown him another truth, one far older and wiser. Strength was not just resistance. Strength was adaptation. Strength was harmony. Strength was movement. He closed his eyes and let the wind push gently against him. The bridge swayed beneath his feet, its motion almost comforting. He realized then why it had survived storms that shattered modern structures. It survived because it never pretended to be stronger than nature. It survived because it learned to move with nature, and that made it invincible. He opened his eyes again, seeing the world differently. This bridge was not a challenge to modern engineering. It was a gift to it. When he returned to the others, there was no arrogance left in him, only quiet conviction. "Maria," he said softly, "I want to help you share this with the world. Not as a curiosity, not as folklore, but as a legitimate engineering achievement." Dr. Reyes felt something warm swell in her chest. She had waited so long to hear those words. "And Mang Thomas," Hoffman continued, turning to the old caretaker, "I want to document every bit of knowledge your family preserved. Not to take it from you, but to honor it." The old man smiled, his eyes softening. "You have listened," he said, "that is enough." But Hoffman shook his head gently. "No, it is only the beginning." A quiet breeze swept through the gorge, stirring the bamboo leaves. And for the first time, Klaus Hoffman felt in his heart what he had always known in theory. Knowledge does not belong to one nation. Wisdom does not belong to one culture. Great engineering is born wherever people learn from the world around them. And some of the greatest teachers are the ones the world has overlooked. The days that followed felt like a quiet revolution. Word of the bridge spread beyond the narrow circle of the summit and the German team. Students from the nearby technical institute arrived with notebooks and hungry expressions. Journalists came with polite questions and concealed skepticism. Even a small delegation from the regional government visited, impressed and bewildered in equal measure. Hoffman was no longer the man who had arrived in Bohol with a certainty that would not bend. He had become an eager pupil, eyes bright with a hunger he had rarely shown in the lecture halls of Munich. He shadowed Mang Thomas whenever the caretaker agreed to demonstrate a technique. He sat cross-legged on the dirt floor of Thomas's workshop and asked questions late into the night. He listened to the cadence of the old man's voice as if somehow wisdom could be transmitted through sound. One afternoon they gathered beneath the workshop's overhanging roof, while the sun filtered through the mango leaves in golden slants. A group of local craftsmen had assembled, some out of curiosity, some to meet the foreigners who had come all the way to see their bridge. They were modest men and women with rough hands, weathered skin, and easy laughter. Their eyes, however, were bright with pride. Mang Thomas began to speak of the rituals tied to building, of the songs the workers would sing as they lifted the first poles into place. He spoke of the exact day to harvest certain bamboo species, of how the moon's phases guided drying, and how the rhythm of songs helped coordinate the strength of those who hauled the heavy beams. Hoffman watched their faces as they spoke, faces that held a lineage of labor, knowledge, and reverence. He began to understand what he had been missing, a communal ethos that preserved knowledge not merely through manuals but through shared life. That evening, Hoffman asked if he could join the craftsmen on a small reconstruction project, a test to see if he could replicate the care and rhythm the elders demanded. They assigned him a simple task: prepare a short span of bamboo railing for a nearby footpath. It was supposed to be a humble exercise, but to Hoffman it felt like a rite. He started clumsily. His hands, used to drafting precise lines and ordering teams of laborers, fumbled with the rattan bindings. The craftsmen watched him with amused detachment. A young woman named Lila stepped forward and gently corrected his grip, showing him how to twist the fibers with a practiced, effortless motion. "Your muscle remembers too much steel," she teased. "Be softer. Let the bamboo tell you where to bind." Hoffman laughed despite himself. The laugh was half frustration, half delight. He worked through the day under the patient tutelage of people who had never taken his classes, but who understood, in ways he was only beginning to, the poetry of structure. At dusk, they completed the railing. It wasn't perfect, but it stood true. The pride on Hoffman's face was visible, and for the first time since his arrival, he felt connected to the hands that had built the bridge generations before. News items began to appear in engineering journals and online forums. Some were skeptical essays debating whether the methods observed were scalable or applicable in dense urban centers. Others were more reverent, celebrating the bridge as a testament to resilience. Academic invitations were extended to Dr. Maria Reyes. Requests to document the bridge increased. Doctoral students proposed collaborations. Hoffman, once the skeptic who had scoffed at the very notion of bamboo as structural material, now championed the bridge. He penned a short piece titled "Lessons from the Gorge" that circulated quietly at first and then gained traction as more respected voices chimed in. He emphasized humility, the need to listen, and the idea that engineering must include cultural practices as valid forms of knowledge. But change in institutions is slow. The bridge's story inspired debate, not wholesale conversion. Some professors defended traditional curricula fiercely, arguing that anecdote cannot replace rigorous standards. They worried that romanticizing indigenous methods could dilute safety and responsibility. In the midst of the debate, a young researcher from MIT visited, intrigued by the bridge's ability to distribute loads. He brought microsensors and drone scanners, and with Thomas's permission, they installed small devices to capture minute movements during wind events. The data, when combined with the Germans' 3D models, formed a richer picture of how the bridge absorbed and redirected energy. The most significant revelation from this new wave of study was simple and profound. The bridge's resilience was not solely in the bamboo's material properties, but in the systemic approach of construction and maintenance. The community's practice of routine inspections, seasonal treatments, and cultural rituals, often dismissed as superstition, functioned as a long-term maintenance plan that extended the life of the structure beyond what chemistry alone could explain. Hoffman worked on a collaborative white paper with the visiting researchers. He insisted the title resist sensationalism. He wanted nothing framed as an exploit. "This is not our discovery to appropriate," he said at the team's first meeting. We are privileged to witness it. We must honor it, credit it, and present it as it is, an intersection of craft, science, and culture. Dr. Reyes nodded in agreement. The two of them found an unexpected partnership, one born from mutual respect and fused in shared purpose. They coordinated workshops, drafted proposals for community-led preservation programs, and wrote grant requests aimed at protecting not just the bridge, but the intangible knowledge behind it. Not all reactions were polite. A few industrial suppliers, companies that profited from conventional materials, published thinly veiled criticisms. Social media, as it often does, turned the story into a battleground of opinions. Some commentators framed the bridge as a quaint relic, others as an emblem of environmental stewardship. A small but vocal minority accused the international team of romanticizing poverty. These critiques stung the locals more than anyone expected. For them, the bridge was not a symbol or a case study. It was home, livelihood, history. Mang Tomas received a stream of visitors, sincere and prying, and occasionally a reporter who asked questions with a tone that implied the village had been saved by outsiders. One evening, after a day when a particularly acerbic column had circulated, Hoffman and Maria sat with Mang Tomas under the mango tree. Tomas's eyes reflected both the weariness of years and a light that never dimmed. "People will always try to take a story and make it their own," he said. "We know that. The important thing is that the work continues." Hoffman, whose words in the broader discourse suddenly mattered, listened. "What do you want?" he asked bluntly. Tomas looked at him as if the question required no thought. "Respect, to be asked how to do our work, not ordered. To keep our rituals alive, to remember that the bridge is more than timber and rope." Hoffman swallowed. "We will do that, I promise." "Promises are light if not held up by actions," Tomas replied. "But it is a start." Hoffman left that night determined to turn his promises into policy. He wrote to his university to propose a new elective, one that would bring students to sites like the bridge to learn under local craftsmen. He used his reputation to push for funding that prioritized community-led research and compensation for local knowledge keepers. Winter came in their own countries while spring turned the Philippines a richer green. Months later, a delegation comprising students, researchers, and a few journalists returned for an extended study. Workshops were organized where local artisans and visiting students exchanged techniques. Dr. Reyes taught alongside Mang Tomas, translating the stories of ritual and caution into comparative lectures about material science and human context. One student, a young woman from Manila named Anna, spoke during a session about the emotional power of place. "I thought engineering was numbers," she said, "but here I learned it is also about belonging. When you build something for your people, you consider their future, their children. You build for continuity." The room hummed with approval. For many visiting students, the bridge became their first lesson in humility, a recognition that rigor must be balanced with respect for the people who steward the land. Back in Munich, the ripple effects were visible in small ways. A handful of professors incorporated case studies on traditional construction into their syllabi. A building firm in Madrid experimented with hybrid systems that married steel frames with bamboo reinforcements in aesthetic pilot projects. The conversation, slow as it was, had begun. Yet through all this change, one thing remained constant: Mang Tomas's daily routine. He continued to sweep the bridge every morning, to check the bindings, to whisper a short prayer before the dawn. Tourists took photographs, researchers took measurements. But the bridge's heartbeat, the tender, patient guardianship of a village, remained unchanged. One evening, years after the German team first arrived, Hoffman returned for a visit, not as a skeptic, not as a conqueror, but as a friend and colleague. He walked the bridge slowly, feeling each flex and listening to the subtle sounds of the place. At the far end, Tomas awaited him. "You kept your promise," Tomas said simply. Hoffman smiled, eyes misting. "You kept yours too." They sat together, looking out across the gorge as light bled into evening. Around them, the bamboo groves whispered in the wind. In the distance, children raced across the wooden planks, laughing. Hoffman realized then that what had changed most wasn't the bridge. It was him, and perhaps that was the point. Structures could teach. Places could change the way a person thought. A century-old bridge made of bamboo had done what textbooks and lectures could not. It had opened a man's heart to a different kind of wisdom. And somewhere down the line, in classrooms and construction sites, in lecture halls and village workshops, the way of building would be different because of it.